Thank you, everyone, for joining. I am going to be talking about using Gen AI. I'm sure you've used or heard about AI quite a lot today, or yesterday. We're going to go through a little bit of live demo as well, so I can show you how it actually works. But most importantly, I will go into the process of how you migrate applications. So it's not about wipe coding. It's not about generating specific code using chatbots. It's actually specifically around how you migrate from one point to another and how do you leverage Gen AI. So yeah, like I said, my name is Shaaf. Here's some details about it. I've been a Java developer for a long time. I also write, etc. So if you want to connect, more than happy to do that. Most importantly, the project that I work with is called Konveyor. It's an upstream open source project. And our job is to make sure that we have tools enough for people to do migrations. Whether it's static code analysis, whether it's more of a project management for enterprise architects, etc. So when you start going into a migration journey, there are certain things you need as part of not just the technical aspects, but also the softer business aspects of it. So as this open source community provides some of those as well. But before I go on, there are a couple of things, just to level set. You've heard about technical debt, I'm sure, many different ways. I'll just put it like this, that let's say you have an application that you've been running for years, you want to upgrade it. Imagine it's a Java EE application written 20 years ago or 30 years ago, or it's any other application written in the last 5 years. As the application changes and the frameworks change, it sort of stays behind in some of those areas, right? So there could be issues with not just the APIs, but the updating of frameworks, etc. So there's sort of like this drift between these two things. Then obviously this kind of makes it difficult when it comes to security risk. So if you've heard about the struts or a log for shell or text for shell, some of those things, and some of these APIs that exist there for such a long time, they also can give you some data breach issues, etc., like that. So we don't want that. We want you to be able to do it much more faster, and I'll show that to you in a demo just in a bit. And then finally, obviously, there's maintenance and costs. So for older applications, you need to manage not just the stack, but also the people. The skills might not be there. As an example, J2E, right? People don't develop in J2E. Anybody develops in J2E right now? No, not me. I shouldn't put my hand up, but yeah, there's one guy there. Okay, so obviously we want to make sure that there are changes that we can bring. What we have today, as an example, in the upstream open source Konveyor community is that we can analyze the source code, we can give reports around it, we can give you data around the exact issues that might be. So let's say you say, I want to migrate from OpenJDK or Oracle JDK 8 to OpenJDK 21. If you're doing Java, that's a huge gap between those two. We are able to provide exact detail about how you would do that. So for example, in Oracle JDK, you would have things like encryptions or sound or text libraries that are not the same when it comes to OpenJDK in 11, 17, 21, etc. You want to make the changes, and we can provide those details for you. So that's something that we already have been doing in our tool today. Once you do that, you can see something like an application inventory. You can go through all the list of all the applications. You can onboard them. You can add the Git repos, and it gives you all those details, right? So it kind of gives you this nice view, which kind of gives you the application inventory. It also gives you things like, the different aspects, like how hard it is to change something. So something might be of high risk. That means that it takes a long time for you to change. It has an impact across multiple components. It could be medium, it could be low. So we can kind of tag those once we do the specific static code analysis as well. If you've seen this code, as long as I've lived, I've seen this. This is almost like 30 years old. It's an enterprise Java bean. I hope you're not still doing it, but it exists in code bases, and about 30 years old, has an RMI IIOP protocol, if anybody's heard about that. And when you bring that protocol into a cloud or container or whatever environment, it's not so easy to change it. It's not so easy to do things like fast failover, etc. It has some specific tied down to the actual platform. And that is quite difficult to change. And what we want to do is we want to change that. This is another example. This is from the string substituter. So if you've used Apache Commons, there was this vulnerability called text for shell. And basically what it did was that it just would execute JavaScript on the runtime on your machine, right? So you don't want, I guess you don't want that. At least I won't. So you want to be able to change that and remove that from your code, right? Here's an example of logging. So log4shell, again, if you were about 2.5 years ago, if you were during the Christmas time hit by the log4shell, you would remember that was a nice Christmas break for all of us, right? Trying to fix that. And logging in general affects the source code that exists across your organization. Like if I'm writing a simple file today, I'd use logging, and imagine how many millions of lines of code is using logging. If you want to change that logging, how much time and effort do you need to do that, right? So it's a long effort that you need to do. So that's all nice. We can do application analysis, and I'll just go into a demo in a bit and show you how that's done. The application analysis, as you see in the screenshot here, gives you the detail about how an incident, for example, in this case, it's looking at specific code, which is the application configuration, and it sort of tells you like, okay, this application configuration has an incident, it's legacy, it needs to be changed. Here's the analytical info. If you want to move this to a Kubernetes environment, you need to add config maps to it, etc., etc. So it's going to give you this full overview of analysis, and that's great. That's not new, right? That's not new. That you can already do with many tools. You know that, etc. So that's been awesome. But as we start to build our tools with Gen AI, about 18 months ago, we were like, okay, how do we make sure that we can take all of this knowledge that we've built with this static code analysis, and how do we actually fix it with something like generative AI? So we have a project called Konveyor AI, and Konveyor AI basically does is that it takes all that static code analysis, adds the generative AI parts to it, as an example. So let me just do this. I'm just going to go in the demo so you can see exactly what I'm talking about. I have my Visual Studio Code open here. I have some of these files here, like my services, as we would call it in Java. I have a catalog service, which does something. I have something called an order service message-driven bean. You can see that it has things like, I hope you can see the screen. If not, just raise your hand if you can't read the code. Okay, let me just, is that better? Yeah? Perfect. Sorry about that. So basically, the order service message-driven bean here has things like Java X. And if you know that Java X or Enterprise Java converted into Jakarta E, which is open source, all these needs to be changed. But also here you will see something like a message-driven bean. A message-driven bean here is basically an old technology as well. Actually, it was built around 92, 93. But we call JMS, Java Messaging Service. It has some of these tie-ins as well. There's something you can use today as well, but not necessarily. There are new technologies that you can use as well. So there's some code here. And then I also have something called a shipping service, which also has some issues, etc. Right? So what I want to do is I want to use generative AI to convert this. So let me show you how I'm going to do the conversion. I have something called the Konveyor AI extension, which is over here, which I've already installed in my Visual Studio Code. I want to configure it, so I'm just going to walk through it a bit around how I configure this. I have something called the analyzer, and now this looks really small, but let me see if it gets better. The analyzer will do the static code analysis, and then I can set some analysis arguments. for the static code analysis. So I could say, okay, this application is Java EE. I want to change it to something like Quarkus. Now I can select Quarkus here as a target for that. Quarkus also has compatibility with Jakarta, so I also want to use Jakarta EE as an example. So I'll add Jakarta EE as well. And once I do that, the analyzer now knows that it needs to do the static code analysis to make sure that it will move all the J2EE application into a Quarkus application, which if anybody has anybody tried that? No? Okay, perfect. So if anybody's tried that, it's quite an indulging process, right? You need days, hours, months, maybe years to do it, right? The next thing I want to do is I want to configure my generative AI model. I have a bunch of options I can use. It doesn't tie you into a specific large language model, so you can choose any large language model you like. In this case, I'm using something that is hosted on OpenShift, which is Red Hat's container platform. I can also use OpenAI, I can use Bedrock, and I can use Ollama, et cetera, et cetera. So it doesn't tie you into a specific large language model. You can choose any large language you like. Once you're done that, you would go and open your analysis panel. So let's go and do that. In my analysis panel here, and analysis could take about 5 minutes usually, so I'm not running this in today's demo. But once I look at my analysis, it comes back and tells me, okay, you have a message-driven bean. EJBs are not supported in something like Quarkus. If you want to do that, you want to make changes to it, right? So there's a couple of things that it's actually listing out for you, saying, okay, these are old ways of coding you need to change, right? So that's what static code analysis is good for. That's something we have used over the years. What Konveyor AI is then doing is, let me start it up, is basically going to convert this using the large language model. So as I start up, it connects with the large language model. As it does that, I can going to filter my order service MDB here, which is my message-driven bean class, and it lists all the different problems I have. It talks about JMS, all the different violations. So if I look at a violation, it says, hey, here's a violation. You can no longer use a text message. So it kind of gives me these intrinsic line-by-line details through the static code analysis. It also gives me the JavaX imports, et cetera, et cetera. So let's do this. Let's see how this works. I'm going to try to fix this using generative AI. I'm going to ask generative AI, hey, could you resolve this issue for me? Please create this code for me. And that goes pretty fast, though, because I've used it many times now in many demos, but I'm just going to run you through it. What we do at this point is that we create a context for the large language model. That context includes each and every analysis issue that we saw in the static code analysis. Usually, when you are doing migrations, at this point, you would go use a chatbot. I don't want to name the chatbots, right? But there are many of them. And when you're doing that chatbot is going to give you a response. And that response might actually not be good or might not be complete. So at that point, what you would do is that you're going to try to re-ask the question and re-ask the question again and again. And it's a hands-on effort that you would want to do. So it could take days, it could take hours, or whatever, right? So it could take time. Here, what we are doing is that we are taking all the information from the static code analysis. There's no chatbot here, at least in the front. And we are taking this, and then we are passing that on to the large language model, each and everything that we actually wanted to be fixed. So it says, please provide the resolution for this issue. Once it goes through it, it passes that information to the large language model, comes back, and then it does certain things. And I'll explain what those certain things are in a second. We have a couple of agents that receive that response and sanitize that response. Why do we do that? We do that because, let's say, you send something to the chatbot said, hey, this is not, gave you a response which is not good enough. You would start to try to compile it, use it. But in this case, we compile it. We make sure that it actually works. Anyways, so it goes through the whole process. It's going to give you a lot more detail about what it's doing, what kind of issues it's trying to solve. So here it's trying to solve our issue number 1, which was the import statement. It gives you certain reasonings. This is what I found out. about your code, and there's some additional information. You need certain libraries, etc., in order, because the J2E libraries are not the same as the Quarkus libraries and should not be the same. So it keeps on doing this. So let's take a look at the end result, because everybody wants to see the end result, obviously. I have the choice here that I can accept this directly or I can actually make changes. But I see that it's already made 20 additions, 37 deletions onto my source code. If you look here, on the left side is the old code, which is the JMS, Java Messaging Driven Bean. On the right side, it has converted this into a reactive messaging. It takes the annotations from here, converts that to application scope. It knows what it needs to inject. It converts the annotation into @incoming over here, because in async I/O, in reactive messaging, you have an incoming annotation, which is doing it asynchronously. So it changes that. It exactly knows what it needs. It has changed the on message. And if you can see here, it also had some JMS exceptions. It also changes those JMS exceptions. So at this point, you have basically converted your JMS into a new reactive messaging. So at this point, all you need to do is provide, let's say, a configuration and a dependency for Kafka, and you can actually run Kafka now from JMS. Right? So obviously, there's some business logic tied to it that you might want to review and make sure, and I'm sure you'll have questions, and I'll answer them. I maybe have an idea what those questions might be, right? So this is at least from Java Messaging Service, which is almost like 30 years ago invented, converted into reactive, which is the latest way how you work with things when it comes to Java and messaging. Let's take another example. Obviously I can accept this and I can continue my journey with this, right? So I can do that. Now I'm going to take another example, which is the shipping service, which I showed you in the presentation. And here it shows that, okay, hey, I have a stateless annotation, perfect. But also, this is a remote EJB. A remote EJB uses RMI IIOP protocol. If anybody knows that or experienced it, it's a different version of RPC, so it's very tightly binded, right? So obviously, this is a way how we have developed J2E code in the past, so it has all of this. What I'm going to do now is I'm going to take this remote procedure sort of protocol and convert this into a REST API. And that obviously is a big change when it comes to migrating your applications. So let's do that. I'm going to go here. I'm going to say, make a fix for me. And it's going to take a while because it's a remote EJB. Remote EJBs take time. So, so it basically goes through the whole context again. It says, hey, I want you to add post methods, use the Java WSRX, use query params, make sure, because remember, EJB is using a method that has a specific class coming into it. It doesn't understand what REST protocol is. So now we're teaching it how to actually do this using the REST protocol. And you can see there's a lot of work that's going on right now. And again, what's it doing is that it's actually going through all of the issues that we provided, and it's actually making understanding and reasoning through it to convert the shipping service from an enterprise Java bean into a REST endpoint. So let's take a look again how that works. Now again, remember, there's no chat here. You don't have to do this 10 times. It's just one time. It's going through it. It's going to take that. It converts these two import statements into all these other import statements. So it's not about just reducing code. It's also about expanding the different aspects of the application. It does that now. It converts, it puts this application scope annotation. It understands that REST needs JSON. Obviously, it should understand that. It adds a path called the shipping/shipping. So now, this should be usable via the REST API. How? You can see on the business function, it puts a post method, and you can see that it adds the parameter, which is the shopping cart. It understands, it's smart enough to know that I need to use this parameter. It doesn't change the business logic. It keeps the whole thing intact, and you can see that it's now converted into a REST endpoint. So again, gives you the possibility. Now, will this work 100% of the time? 90% yes. What's the 10%? 10% might be the knowledge that the large language model doesn't have. Maybe the static code analysis did not cover certain use cases. So obviously you need to also have your indulging a bit into the static code analysis as well. Another thing that I did not talk about, and I'm just going to do that quickly. So if I go back to the presentation, what's happening is that, yes, we can use the static code analysis, combine that with it, but I think the biggest important factor is that you can choose whichever model you want. You can have your own trained model and use this. You can use Llama, you can use Granite, you can use any of the code models you like. And why? Because you could have multiple responses that fit towards your large language model. So that's pure. What's happening then, obviously, is that the most important part, I think, is this is not like a Copilot, this is not like a cursor. All of those are more indulging. You write this. This is purely for migration. So if you're looking at doing migrations, you want to be able to have a flow that specifies exactly how you want to do it, rather than asking the same question 10, 15, 20 times, not knowing the answer. As you saw that in the demo also, it shows all the different details about how it's actually coming to the fix. So static source code analysis creates the context in a RAG and then uses the large language model, which means that you do not need to fine-tune your large language model or use a fine-tuned model to do this. It will automatically do it. If you say, I want to containerize my application, the static code analysis rules are going to check all the different things like JNDI lookups, IPs, etc., and it's going to tell you what changes you need in order to put something on something like Kubernetes as well. It comes as a VS Code extension. The thing that you didn't see, and the thing that's not visible, is that there are specific agents that are in play here. So once you change the source code, once we receive the source code, and you see that it takes a little bit of time and there's a lot of log going in there, the first thing it does is it receives the large language model response. Once it receives it, it tries to sanitize it that it is the right response. And what it does is that it runs a compilation agent to actually compile the code that it's actually getting. So I had 30 issues in my file. I could actually now go through the compilation and see that it actually works. So once Konveyor leaves your code base or has given you a fix, it is a fix that is a working fix, and that's important. So it is agent compilation, there is caching, there is planning, etc., all of those different aspects in the code as well. If I just quickly go back to the demo, obviously there's tons of files. Like you see, here's 149 incidents. And you might think like, hey, I want to fix all of them. So yes, you can fix all of them as well. It's going to come back to you, but then you would have to review through each and every of them and do all of that yourself. A leading question that you might not have asked me and you might have in your heads is that, hey, I also want to create tests because I was using JMS and I was testing differently. Now I'm using reactive. What about EJB was different, REST is totally different. Obviously, you need to create tests, and that is a responsibility a developer needs to have in order to make sure that the contract of the application actually is fine. Furthermore, you can, like I said, this is the flow, how it works. You can take applications that are Java applications today. We are only specifically focusing on Java applications as the first community release is pretty much on our way. In a couple of days, you will find the first community release. And yes, we are open to contributors if you feel like you want to contribute something. But we also have possibility to do static code analysis on Node.js, on Golang, on .NET as well. But at this point, we start with Java as the first one. The developer environments are VS Code and IntelliJ. And then obviously, you can use any large language model as you feel pleased to do so. So I'm just going to do here is that I'm going to say, hey, I feel really nice. I want to be able to fix. When I say fixing, there is low effort, medium effort, high effort, as you see this. And this is also important. If I fix something with medium effort, so I could go back to my order service MDB, and I can say fix this with medium effort. It's going to take a little bit while. It's going to go through the agents again. But in medium effort, it's important what it's going to do is, it's not just going to fix the file, it's also going to try to fix its dependencies. And that's important, which means that if you have any code that actually touches this code, it's going to try to fix that. It's going to try to fix your application properties. It's going to change your POM XML, all of these different things. If I went into trying to fix something on, which now it's fixing right now, but on a higher level, then it will actually go even deeper than the first touch points, actually go further to other dependencies as well. So it has that possibility to do that and helps you to do migrations at faster speed. So what have we really achieved if we put it like this? We've actually reduced the time of how you migrate an application. We're not saying that you can magically change, automatically change entire application. We're saying that you've actually accelerated the time of how you migrate your application, and that's how you should see it. So the user flow, just to bring it all together, looks something like this. As a developer, you check out the code, you configure your targets as to what your migration plan looks like. You do the static code analysis, and you get all the details of what difficulties you might have doing migrations, and then we take that and put it into the context, ask the large language model to fix it for us, we create a patch for you, and then your migration is most likely complete, right? So that's how the process works. At this point, I will say thank you, but I'll also leave you to the QR code. That's for the Konveyor IO project. You can go on that page. You feel like you want to discuss something, we are very open to it. We are open to contributors as well. We work with many different contributors like IBM, Microsoft, etc. at this point, and this tooling is also part of their products as well. So thank you so much for listening. If you want to connect, I'm happy. If you have questions, I'm also here.